Okay, so we're going to do a side-by-side review of the LFSR polynomial code. Okay, so this is the original, and you can see it's derived from an abstract set. So that comes in here, and then that requires these functions. Now the thing is that you notice from the pattern here that all of these use self.exponents. So, and self.exponents is a frozen set. So why not just inherit from set? And half the class goes. That's an automatic result. So that's all gone. I liked the value checking the incoming result. To get it onto 80 characters, I changed from for exponent in to for e in, and then added these some messages, and deliberately did reaper brackets e using %s there, because whatever type that is, reaper on it will get it to print out. Yeah, you get the idea. Same not with this one, because by this time you know it's an integer. So that function, it just set dot underscore net. Yeah, I know. I'm not a fan of super. But it grab all of those elements and just put them into the set, and you don't need to you don't need the abstract overrides. It's the difference, but in Python 2 you couldn't do this. You couldn't derive from dict, list or set. You had to use user dict and user list, which are still around. I tried deriving from frozen set here and here, didn't like it, don't know why. It's probably actually a bug in Python 3. It was complaining about object dot underscore init, and yeah, bleh, nonsense. You've got self dot underscore exponents equals something, and then returning exponents as a property. The only primary reason for using properties is if you're going to do something different from what the variable is. So if it was return function on self dot underscore exponents, then yes, you would do that. You would add a property, but not doing that, therefore it is redundant, and you just assign the thing to thing. Now in this case, originally I did actually put self dot underscore exponents, so self dot exponents equals frozen set of elements. However, later a second topological morph did actually return processing of the thing. Now it does list bracket self, which calls the set dot underscore iter underscore to yield the elements of the set, which passed to a list. You can then list dot sort, blah blah blah, and you're done. Okay, so here you have so the second code morph that I did was to move that into here, and it's identical there to that. Therefore, just in here, just do self.exponents. Blumph. Done. This went through two code morphs. The first one was to remove separator as a thing and replace retval with a list accumulating the stuff. This is a trick that I've done from a lot of text manipulation stuff. Excuse me. There is a function in string called join, and you pass the list and it joins the things together. Default, I think, is a space. It's not very well known that string has this join function that takes a list, and I get it wrong, and I do retval.join brackets plus because I keep thinking it's part of list. It's not. It's really, really useful. The second thing was the next bit was I went, yeah, there's got to be a way to do this. And it's if I equals 0 is that, if it's I is that, else that. Okay, so what if we max I comma 2 and then use min I comma 2, then use that to look up in a dictionary, and the values in the dictionary should be 0, 1 and 2. So there we go. There's the dictionary. 0, 1 and 2 returns 1, x and x exponent to the power of blah blah format. And I really don't like listing comprehensions. They force people mentally to put the item on the stack, and it also forces Python interpreter, the parser, to put extra state on the stack. It's like x equals list of x. Oh, for this, it's like x equals x. For x, for the thing. Oh, give me a break. You know, map, function, list, done. I had an opportunity a long time ago before they got silly about the Python thing to make the suggestion that list, dictionary and all iterables have a .map function added. The reason it wasn't added is because the person who proposed map, lambda and reduce was a Lisp programmer back in Python 1.5 about 21 years ago. That's the reason those functions exist. Unfortunately, because he was a Lisp programmer, he did not propose that they be added in a function in a Python-like object-oriented fashion. Oh well, never mind. Anyway, so lambda on the dictionary grab I, min it between 0, 1 and 2, and dot format brackets I. There's probably a better way to do that, but honestly, it's 3 lines where the original is 14. So happy with that. The string there just passed in percent. I quite like %s. I know it's nice to have the locals, local variables and stuff from from format things put in there, but 1 line, 3 lines. This is excellent. These polynomials are really good. Right, here's what I prepared earlier is I worked out if I go down to there, those days. One too many. Excellent. Okay, so again the same thing with the property polynomial. Not doing anything to underscore polynomial, just assigning it and then returning it as a property. So get rid of the underscore and just set that thing so it's not being processed. boop, gone. Width, on the other hand, excellent. Returning the max exponent. Same for this one as well. Retaining that is good. So those three lines pretty much stay the same. I removed the 1 comma as the width. Nobody's using signal brackets 1. It's going to surprise people. Both within the team and outside of the team, to think they're going to see that and go, why is that there? Principle of least surprise. Reset equals 1, great. Reset equals 1, great. Okay. That stays the same, but I changed this to from feedback equals feedback exclusive or to feedback exclusive or equals. Save some things. Also, this if self width greater than 1, I moved that to here and commented it that if the width is 0, do nothing, return an empty module. It saves on indentation of this block, which it's particularly if you have multi indentation, it's a really good idea to take every opportunity you can to not have indentation. The only thing is that because of these are with things, the standard Python tricks that you would normally do, you can't do it. So in some cases you can't mix Python ifs with nmigen state-based ifs in that fashion. It gets very hairy. You have to be quite careful. The assigning the state is sync here to bits 1 to self dot width and then 0. That's equivalent to doing cat. It's within the self dot enable, so it's not, none of it is non-optional. It's all the same sync. So cat, the LSB is from left to right because that's the Python convention. So they're following that. So the LSB is feedback, which is bit 0, and then the remaining bits sync. Now, strictly speaking, we could get away with not having that self width -1, and when it gets assigned, silently it will be truncated. It is, however, I feel that it's not a good idea to take advantage of that and to do just exactly as you did, to put that in there. So that's a good thing there. I can't think of a way to stop that feedback equals const 0 from being in there without having extra lines of code. So yeah, just left it in. Let me just grab the. I don't know if the screenshot thing will move here, so I'm going to move that onto where I think the screenshot is being captured. That looks really good. That's FSM 24, LFSR24. Yeah, that's results of this is what I showed you, because we've got this exclusive OR chain. There is a function .bool which does an OR of all bits in nmigen, and it uses the Yosis bool function or block, but unfortunately it doesn't look like there's any equivalent for operators which take bit manipulation as a group and produce something. So consequently you've got this chain, which is a bit messy, and hopefully Joseph will optimize this to a reduced tree, so that we don't have to do that. Right. 123 lines. 120 lines. However, I've got some comments in this block, which make it the same, roughly. If you took out the comments, it would be the same length. But this one is the main one that's been hugely reduced down to an initializer, constructor, and store and reaper. Yeah, this is actually we could hypothetically even just get rid of reaper, but it's nice to have that there. Actually showing the polynomial brackets thing. I can't remember if that's more along the lines of the convention that it's supposed to do. Can't remember. Anyway, yeah. So just a summary then. Properties. If you're not going to do anything with the properties, with the actual thing, just returning a variable, no, don't do it. If you need to process, the only reason for doing properties is if you need to process the thing, or if you need to make it read-only. There is a set getter or something like this, which makes it read-only, because there's no setter now. So that would be a good reason to have that. Honestly, the type information is so interfering with readability. I moved it to PYI file. I can't handle it. I didn't spot during the creation of the PYI file. I didn't notice that this was initialized to a static tuple, and removed it. Not knowing it was there. Again, LibreRISCV something principle LSP self.polynomial. Yeah. Why? Why? You don't need it. You just don't. A thing. I hope that the MyPy picks up the .pyi files, so that life is easier for you with you're used to the timer. But yeah, I'm seeing a lot of abstraction which is just not necessary. So as I said, be much more direct in things. Use these tricks that there's a set and you can derive from it. Don't derive from an abstract class and create the things when the thing that your self.exponents is a set. So put the set in the thing. Yeah, you get the idea. Yeah, it's it's going to make a huge difference to readability of the code. All right, cool. Thank you very much.